What provides us with the air we breathe? And what brings us the weather we experience every day? What protects us from the potentially harmful rays of the sun? What allows radio waves for television and radio transmission to travel to us? And through what medium do planes, satellites, and meteors travel? The answer is the atmosphere. The atmosphere that surrounds the Earth contains the gases essential for the survival of living things, including humans. The atmosphere of planet Earth is extremely unique, playing a major role in supporting life. No other planet in our solar system has an atmosphere like Earth's. During the next few minutes, we're going to explore some of the unique features of planet Earth, with special attention to the characteristics of the atmosphere. In what ways is the Earth similar to this apple? The region of Earth where life exists is equivalent in thickness to the skin of this apple. It's a very thin zone. What factors contribute to life on Earth? One thing that makes Earth unique is the abundance of water. Often referred to as the blue planet, over 70% of the Earth is covered with water. This photo of the Earth taken from space shows the abundance of water. The water on Earth makes up the hydrosphere. The hydrosphere consists of the oceans, rivers, and streams, as well as ponds and lakes. Glaciers and the polar ice caps also can hold a great deal of water, contributing to the hydrosphere. The Earth's crust is the solid layer of the planet, known as the lithosphere. We live on the visible surface of the Earth's crust that we call land. Only about 30% of the Earth's surface is land. The remainder of the lithosphere exists underwater, underlying lakes and oceans. The lithosphere under the oceans is largely unexplored, and we're still learning a great deal about it. Every time you take a breath, you're breathing in part of the atmosphere. During the course of a day, you breathe approximately 26,000 times. We need to breathe to survive, as do plants and animals. You decide. What gas in the atmosphere is vital to our existence? Oxygen is an extremely important gas that we breathe in. Our bodies need oxygen to carry out everyday activities. And plants produce oxygen during the process of photosynthesis. But oxygen is just one gas among many gases in the atmosphere. It makes up just 21% of the air around us. The most abundant gas is nitrogen, making up 78% of air. As we just mentioned, we breathe in oxygen, but we exhale a gas called carbon dioxide. Carbon dioxide makes up only 0.03% of air. Water vapor is another gas which can make up from 0 to 4% of air. There are many other gases which make up air, including argon, neon, and helium, to name just a few. The atmosphere also contains many tiny solid particles. The smog seen here in the Grand Canyon consists of small particles of dust and pollution floating in the air. If you view light at the correct angle, you can actually see tiny particles in the air consisting of dirt, smoke, dust, and even ocean salt. As we just discussed, People and animals breathe in oxygen and breathe out carbon dioxide. But where does oxygen that we breathe come from? Plants play a vital role in supplying Earth with a continual supply of oxygen via the process of photosynthesis. Large plants, including trees, take in carbon dioxide and give off oxygen. And microscopic plant-like organisms abundant in the oceans are believed to be responsible for a large amount of the global oxygen supply. Carbon dioxide and oxygen are continually cycled between plants and animals. Skiers at high mountain altitudes often become short of breath, and breathing is more difficult. But at lower elevations, they find breathing easier. Why? The answer lies in differences in the atmosphere. At higher elevations, there's less oxygen in the air than at lower elevations. The atmosphere can be divided into different layers. The different layers are divided according to major differences in temperature. You decide. What force holds the layers of the atmosphere to the Earth? Gravity. Gravity is the force that pulls objects, such as these stones, toward the Earth. Like the water in this waterfall, gases in the atmosphere are also pulled toward the Earth by gravity. The atmosphere extends hundreds of kilometers above the Earth's surface. The weight of the gases aloft pushes down on the air below. This causes the gas below to become compressed and denser. The air closer to the Earth is denser than the air further up in the atmosphere. Consequently, as you go higher up in the atmosphere, you experience less air pressure. Temperature also plays an important role in delineating the layers of the atmosphere. Different layers of the atmosphere have different temperatures. Different layers of the atmosphere also possess properties which affect temperature. Let's take a closer look at some of these layers. We eat, walk, and live in the bottommost layer of the atmosphere called troposphere. The troposphere contains the oxygen we breathe and the weather we experience. The height of the troposphere varies from 6 to 8 kilometers at the poles to as much as 17 kilometers at the equator. The Earth's surface is the primary conduit which heats the troposphere. Therefore, temperatures decrease as distance from the Earth increases. The temperature decrease is about 6.5 degrees Celsius for every kilometer above the Earth's surface. This is one reason why it tends to be colder on mountaintops than in the valleys below. At about 12 kilometers above the Earth's surface, the tropopause separates the lower troposphere from the stratosphere above it. If you've ever traveled on a jet plane, chances are you flew through the stratosphere. The stratosphere extends from the troposphere up to about 50 kilometers above the Earth. It's very cold there, with temperatures around minus 60 degrees Celsius. Bands of strong winds with speeds up to 320 kilometers per hour, called jet streams, blow in an eastward direction. Jet streams are important forces influencing weather patterns. The streams also help planes arrive at their destinations sooner. The stratosphere also contains a thin layer of gas called ozone. Ozone is very important in absorbing ultraviolet radiation from the sun. Ozone protects plants, animals, and humans from receiving too much ultraviolet radiation, which can be harmful. Harmful pollutants can damage the ozone layer, creating large holes, shown here in blue. This increases the risk to life on Earth, allowing too much ultraviolet radiation to reach the surface. Because ozone absorbs heat energy from the sun, temperatures in this layer tend to be warmer at around 18 degrees Celsius. The stratopause separates the stratosphere from the mesosphere. The Earth is continually bombarded with rock fragments from outer space called meteors. The mesosphere, extending from 50 kilometers to 80 kilometers above the Earth's surface, protects Earth from meteors by burning them up. The heat created by friction between the atmosphere and the meteoroid causes the burning. The mesosphere is very cold, with temperatures around -100 degrees Celsius. Above the mesosphere is the thermosphere. Thermo means heat, and this layer is extremely hot, with temperatures reaching 2,000 degrees Celsius. This is hot enough to melt steel. The thermosphere is divided into two layers, the ionosphere and the exosphere. The lower part of the thermosphere is referred to as the ionosphere. It extends 80 to 550 kilometers above the surface of the Earth. Here, particles of gas, called ions, become electrically charged. These ions play an important role in transmitting radio waves. AM radio waves bounce off ions in the ionosphere back to Earth. At times, disturbances in the sun, called solar flares, can cause fluctuations in the ions in the ionosphere, interfering with radio transmissions. Above the ionosphere is the exosphere, the upper region of our atmosphere. The exosphere extends thousands of kilometers above the surface of the Earth. Here, the air is very thin. Satellites orbiting the Earth travel in the exosphere, as does the space shuttle and the space station. You decide. What's the name of these colorful lights in the sky? These brilliant colors are called the northern lights, or aurora borealis. The magnetosphere plays a key role in forming these lights. The Earth acts like a giant magnet, creating magnetic forces which extend thousands of kilometers into space. As the sun emits a fast-moving stream of ions, referred to as solar wind, the magnetic field of the Earth traps the ions. The belt of charged particles surrounding the Earth is referred to as the Van Allen radiation belt. When the sun bombards the Earth with large quantities of ions, they get trapped in the magnetosphere. Here, they come in contact with particles in the ionosphere, causing them to give off light, leading to a spectacular display of colors called auroras. During the past few minutes, we've taken a look at some of the features of our planet, including the hydrosphere, the lithosphere, and our atmosphere. We explored the different gases that make up the atmosphere around us. We considered how temperature and pressure play a role in creating different characteristics in the layers of the atmosphere. And we took a closer look at the different layers of the atmosphere, including the troposphere, stratosphere, mesosphere, and thermosphere. So the next time you take a breath of air, tune in the radio, ride on a jet plane, or look up in the sky, Think about some of the different characteristics of the atmosphere. You just might look at your world a little differently. Fill in the correct word when you hear this tone. Good luck, and let's get started. Number 1. The hydrosphere contains Number 2. Only about % of the Earth is land. Number 3. The most abundant gas in the troposphere is Number 4. Plants are vital in supplying us with Number 5. Layers of the atmosphere are divided according to differences in Number 6. Air closer to the Earth is than air higher up. Number 7. Jet streams are located in the Number 8. Plays a key role in absorbing ultraviolet radiation. Number 9. Is the layer in which meteors burn up. And number 10. Satellites travel in the